Hey everyone, my name is William Avila. We'll share a brief summary of the project Line Follower with cues control carried out in the analog control course. Well, this project consists of building a vehicle capable of following a line wheel while catching up the another vehicle and always maintaining the distance assigned by the user as the set point or input value, which range from 10 centimeter to 60 centimeter when the vehicle was outside the assigned range. It had to reach the target as quickly as possibly. So speed also played an important role. Oh, right. Well, and the car had to be built entirely with analog components, no microcontrollers for the line following system. Use the sensor, the CNG's 70 sensor were used along with analog photosensitive sensors. The logic used to change the motor direction was based on switching the transistor on and off. The the payload controller for a line follower the key project components are four components: the PID, uh, sensors, PWM, and bridge H. Distance sensors to be characterized this to determine the voltage value at the given distance. For example, at 20 centimeter, the sensor output was 1.5 voltage. At 30 centimeter, it was 2 voltage, etc. These values were then assigned to the potentiometer, which fun, function as our set point. The PID controller of the circuit was also complex, as it had to be turned by varying Kp, Ki, and Kd. In the end, the distance controller worked. Barrett has PD controller since the integer had very small value. They generate the PWM for the motor and an integer and a 500 55 timer is was used from an DC voltage it generate and software signal, which was then modified through compiling stage amplification and zooming circuits to be used and comparative with 12 voltage DC reference. They tried the motors and traditional H bridge module was used to control the motor speed and switching. Well, the challenge and solution. We have three challenge. Challenge. Sorry. The first, PID constant tuning, and sensor calibration, and power supply. And in the case PID, a price adjustment of the KPI and KD constant was essential to avoid excessive correction and achieve movement and stopping and the assigned distance. The second was sensor calibration. The calibrating the infrared sensor was essential in order to adapt to different light condition and surface type. The analog ultrasound sensor must be characterized in order to adjust the potentiometer. The finish was power supply. The power supply was a major challenge as the motor consumed a lot of current and has the battery voltage decreased the distance by the malfunction function. Yeah. The results, the car was able to correct the distance every error very quickly. The only persistent problem was the line following system, since the track conditions were not ideal. Sometimes the car will go off track. However, when the test in a better area, this error was correct. Thank you very much.